Hi everyone, let's take a look at the following example. For each of the following functions below, find all the first order partial derivatives. Part A, f equals to x squared times y plus x cubed times y cubed. So again, by inspection, notice f is a function in terms of x and y. So again, when you see f in brackets x comma y, this means the function f is expressed in terms of x and y. Now, here's the first part of the answer. If you want to find f subscript x, this really means in English, find the partial derivative with respect to x. So again, this means find the partial derivative with respect to x, which means everything else is going to be a constant. So in this case, you think about y as a constant, and you're going to differentiate this with respect to x. This means this equals to, again, you find the derivative of x squared using the power rule, that's going to be 2x. And you copy the constant y. Plus, likewise, when you find the derivative of x cubed, again, that's going to be 3x squared times the constant y to the power of 3. Now, likewise, if you want to find the partial derivative with respect to y, it means everything else, which means in this case x squared and x cubed are constants. So again, if you're looking for the partial derivative with respect to y, think of x squared and x cubed as constants. So I go back, I take the derivative of y, which is basically 1. So this equals to 1 times x squared, which is x squared, plus, and I take the derivative of y cubed, that's going to be 3y squared. And notice the way I write this, 3y squared, and I copy the constant x cubed, just like that. So again, that's the answer for part A. Part B, let's use a slightly different color. Here we go. In this case, again, f is a function in terms of x and y, which equals to e to the power of 3x plus 2y minus 10 of x y squared in brackets. So again, we're starting with the partial derivative with respect to x. Now, a couple of concepts you want to remember, just in case. Don't forget, when you find the derivative of e to the power of x, this equals to e to the power of x. And of course, if you're finding the derivative of e to the power of a function, f of x, this equals to e to the power of f of x times the derivative of f of x. Now, another idea, just in case you need a refresher, this includes if you're finding the derivative of 10x, this equals to secant square x. Likewise, if you want to find the derivative of 10 of a function f of x, this equals to secant square of f of x times the derivative of f of x. Okay, so back to part B. So again, if you want to find the partial derivative with respect to x, that means y in this case are going to be constants. So you go back, you start with e to the power of 3x plus 2y, which means the derivative is going to be e to the power of 3x plus 2y times the derivative of 3x plus 2y with respect to x. And again, if you differentiate that, it's going to be 3, which I'm going to put at the front, minus, when I take the derivative of 10 of x times y squared, again, it's going to be secant square of xy squared times the derivative of xy squared with respect to x. And again, when you differentiate x, that's going to be 1. And 1 times y squared is going to be y squared, which I'm going to put right there. Let's keep going. To find the partial derivative with respect to y, this is going to be, again, you think about x as a constant. So I go back to the beginning. I take the derivative of e to the power of 3x plus 2y, which equals to e to the power of 3x plus 2y, times the derivative of 3x plus 2y, which is going to be 2, which I'm going to put at the front. Again, minus, when I take the derivative of 10 of xy squared, that's going to be secant square of xy squared times the derivative of xy squared. And again, when I differentiate y squared, that's going to be 2y, and I copy the constant x just like that. Now, for parts C and D, I would like you to try this first. Press pause, go through both parts, and when you're done and you press play again, I'll be here. Part C, let's zoom in for you. Again, you're looking at a function in terms of x and y, which equals the cosine of the square root of x times y plus sine of x cubed times y squared. So we're starting with the partial derivative with respect to x. Again, this means everything else are constants. So y and y squared, think of them as a constant. When you take the derivative of cosine, that's going to be negative sine. So again, negative sine of root x times y. And now you multiply by the derivative of the square root of x times y. Now again, just in case you forgot some of the basics, I'm going to write this down on the side for you. So again, this goes back to the basic power rule. If y equals to root x, this means y equals to x to the power of half. To find the derivative, this means you have half times x to the power of negative half, or 1 divided by 2 times x to the half, which becomes 1 over 2 times root x. So again, when I take the derivative of root x times y, this equals to y, which is the constant I'm copying, divided by 2 root x. Now, if I look at the second part, when I take the derivative of sine of x cubed y squared, that becomes cosine. So again, I put a plus sign. Let me erase this now. And I write down cosine of x cubed times y squared times the derivative of x cubed y squared with respect to x. When I differentiate x cubed, that's going to be 3x squared. And I copy y squared, just like that. Now, if I'm looking for the partial derivative with respect to y, again, this means x is going to be a constant. So x cubed and root x are going to be constants. I go back. This means, again, when I take the derivative of cosine of root x times y, that's going to be negative sine of root x times y times the derivative of root x times y. And when I take the derivative of y, that's going to be 1. 1 times root x is going to be root x. Plus, when I take the derivative of sine of x cubed y squared, that's going to be cosine of x cubed y squared times the derivative of x cubed y squared. And again, when I take the derivative of y squared, that's going to be 2 times y, and I copy the constant x cubed just like that. Part D. Let's switch to a different color. We're finishing strong. Now, notice in part D, the function f is expressed in terms of x, y, and z. So in the first case, if you want to find the partial derivative with respect to x, that means y and z are constants. So again, y squared, ln z, and this e to the power of 2z are going to be constants. Okay. So this equals to, again, since this is a constant, the derivative of a constant is going to be 0. When I look at the second part, again, think about 3x and e to the power of 2z is 2 separate parts. So again, when I take the derivative of 3x, that's going to be 3. Then I copy e to the power of 2z. So again, this is basically 3 times e to the power of 2z, just like that. Now, If I'm looking for the partial derivative with respect to y, again, this means x and z are constants. So again, x and z are constants. I go back. When I take the derivative of y squared, that's going to be 2y times ln of z. Since x and z are constants, when I differentiate this second part, it's going to be nothing. Or this basically is going to be 2y times ln z. Last but not least, if I'm looking for the partial derivative with respect to z, that means x and y are going to be constants. Now, don't forget, when you find the derivative, and I'll write it down right here just in case you want to get a refresher of some of these basic concepts. When you want to find the derivative of ln x, that's basically 1 divided by x. And if you want to find the derivative of ln of f of x, then it's going to be 1 over f of x times f prime of x. So in this case, when you find the partial derivative with respect to z, in this first case, the derivative of ln z is going to be 1 over z, and I copy y squared at the top, just like that. Now, if you look at the second part, when I find the derivative of e to the power of 2z, that's going to be e to the power of 2z times the derivative of 2z, which is going to be 2. I copy 3x, which is the constant, just like that. So this means this equals to y squared divided by z plus 6x times e to the power of 2z. I hope this makes sense.